So in this video, I want to introduce something completely different. Rather than just kind of tell you what I'm going to introduce, let me show you why we are introducing this new concept. We're basically going to go back to Newton's laws of motion and re-explain them a different way. So in some sense, this is nothing new, but in another sense, this reinterpretation is actually incredibly important and allows you to solve some really difficult problems that would be, very intimidating with the methods you know so far. But once you understand this new method, you might even be able to just look at them and solve them conceptually right away. So to start out with, our main idea, our kind of main focus has been F equals ma. So let me fiddle around with F equals ma and see if I can put it in a form where we'll interpret it a little bit differently. So when you write it in this form, F equals ma, the interpretation is basically that forces cause acceleration, and then acceleration results in a change in the object's velocity. And when the object's velocity changes, well, the way it changes depends on the object's mass. So the object's mass resists the effect of forces. And you might be able to see already that it's a little bit convoluted. It makes sense, but it's a little bit not so elegant. So is there kind of a way to clean this argument up a little bit? The way we're going to clean it up is that we also learned that on average, the acceleration is equal to delta v over delta t. So if we plug that expression in to F equals ma, then that will mean, well, let me actually do this a little bit carefully. That will mean that the force on average is going to be equal to the object's mass times delta v over delta t. Let me write that out longhand. Delta v is v final minus v initial. Distribute the m through, and you get mv final minus mv initial. And if you want to reinterpret this a little bit, what you can basically say is there's a thing here, m times v in the final state minus m times v in the initial state over delta t. So let's give this a name. Let's call it P, is the conventional choice, is mv. And if you do so, then you find that the average force on the object is equal to delta P over delta T of the object. And you get, although P is very abstract, what the heck is P? But if you just are willing to put that aside for a moment and not worry about what P is, you can see here that this has a very simple interpretation, which is when you exert forces on an object, it causes the P to change. It causes the object's P to change, whatever that means. But there's no mess about mass, and there's no mess about, well, different objects will respond to forces in different ways. It depends on what the object's properties are and all this nonsense. No, all objects respond exactly the same way to forces, and that way is that their P changes. And the P will change depending on the force, period. And you get a really simple, really clean interpretation of Newton's laws. The price you pay for that is that now you have to work in this quantity called P instead of working in the traditional variables of motion, position, velocity, acceleration. Now you're working in P as the main property of an object's motion. So what is this quantity? Right? So P, which is mv, is called the object's momentum, and it represents if I try to come up with a way, it's a little bit of an abstract quantity in some ways, so it's a little bit hard to explain in words. The mathematical definition is really simple. What does it mean in words? The way I would say it is it represents an object's total amount of motion. If there is such a thing in, like, if it makes any sense to ask the question, how much motion does this object have? The answer to that question would be the momentum. So the advantage of momentum is that it contains all the information about the motion in one quantity, including the object's mass is in there already. So you don't have to worry about like different objects behaving in different ways, because if you're thinking in terms of momentum, all objects obey the same rules. All objects behave the same way. So let me explain how this changes Newton's laws of motion. Maybe I'll do that in the next video.